Only NOT gate takes the maximum itself 1 input. The remaining all gates will take minimum itself 2 input. See the second case, 1, how many times here we have? 2 times. 2 means it is even. If for even you write 0. In exclusive OR gate, we will count how many times 1 is there. If it is odd number of times, then we'll write 1. Welcome to one and all. Myself, Vasanta, lecturer in Computer Science, Vidhyaashram PU College, Temple of Excellence, Mysuru. Today, we'll start with the second session of Logic Gates chapter. Whereas in first session, you come to know the introduction regarding what do you mean by logic gates, which are the basic gates, how to write the symbol as well as truth table for that basic gates. Regarding that, you come to know. That is, logic gate is nothing but simply an electronic circuit. It takes one or more input signal, it produces output signal. Under basic gates, you have studied regarding AND gate, OR gate as well as NOT gate. These are the three things you have studied in the previous class. For all the three, you have studied the symbol as well as truth table. Truth table you have studied in the previous class. Whereas today you will come to know what do you mean by derived gates. Under that, which are the derived gates, that is NAND gate, NOR gate, XOR gate as well as XNOR gate. With that, you will come to know regarding the circuit diagram, how to write a circuit diagram for the given equation. Regarding that, you will come to know on this session. Whereas already you know what do you mean by basic gates as well as derived gates. Under basic gates, AND gate, OR gate as well as NOT gate you have studied. Whereas today you will come to know regarding the derived gates. What do you mean by this derived gates? The name itself suggesting that it is derived with the help of basic gate only. The name itself suggesting derived gate. It means that it is derived with the help of basic gates. When they come on types of derived gates, the first one NAND gate, NOR gate, XOR gate as well as XNOR gate. These are the 4 derived gates you will get under derived gates. First one by one we will explain. The first one is NAND gate. The NAND gate has 2 or more input signal and it produces one output signal. Whereas already I told you, only NOT gate takes the maximum itself 1 input. The remaining all gates will take minimum itself 2 input. Here also in NAND gate also it takes 2 or more input signal and it produces 1 output signal. NAND gate is complement of AND gate. It is just reverse of AND gate. Reverse of AND gate, and the output of NAND gate will be 0 when all the inputs are 1. Otherwise it is 1 here. That I will explain one by one. Whereas this is the symbol to represent the NAND gate. See, first we will write the AND gate symbol. That is here X and Y are the input. Then what is the output here I am going to get? X into Y. Once if it is passed from NOT gate, then X into Y whole bar. Already I told you, NAND gate is a combination of NOT gate as well as AND gate. Here this is the NAND gate symbol and this is the NOT gate symbol. Whereas this is a symbol you have to write for NAND gate. Then if you want to write the truth table, see here when all the inputs are 1, then only the output become 1 here. See, when all the inputs are 1, then the output become 0 here. That is, see, first 0, 0, then 1. 0, 1, 1, 1, 0, 1, double 1, 0. For example, if you are not able to write directly, then you can use AND gate pattern also. Here, for example, X and Y. First find out X into Y, then find out X into Y whole bar. Then also you will get the same result. For example, 00, 11, 01, 01. X into Y means AND operation. AND means if all the inputs are 1, then only output become 1. Otherwise, here 0. See, first case 0 into 0, 0, 0 into 1, 0, 1 into 0, 0, 1 into 1, 1. Then whatever result here we get, that is X into Y, whatever result you have, just reverse that to find X into Y whole bar. That is 0 here, then here 1, here 0, 1, here also 0, 1, here 1, that's why here 0. When all the inputs are 1, then only the output become 0. Otherwise, here it is 1. If you want, you can write like this way or this way. Whereas NAND gate is a combination of AND gate as well as NOT gate. This is a symbol for 2 variables and this is a symbol for 3. This is the symbol for 2 variables and this is a truth table for 2 variables. Whereas if you want to write the symbol for 3 variables, because in the exam, you have 1 marks 1 question, 2 marks 1 question as well as 3 marks 1 question. There you may going to get a question, write the symbol as well as truth table for 3 variables. Or specifically sometime they will ask, write the symbol and truth table for 2 variables. See, if this is the symbol to represent the NAND gate. See, minimum 2 or more inputs, whereas here I took for 3 variables. For 3 variables, the symbol is like this pattern. Minimum 3 inputs, then here at the end negated, then output. That is the output we are going to get x into y into z whole bar we are getting. In the same way, when all the inputs are 1, then only the output become 0 here. See, already I told you, here only we are going to get 0 when all the inputs are 1. Otherwise, we are going to get the output is 1 here. Now, is it clear? See, here 3 variables means 2 to the power of 3. Totally 8 combinations will get. 8 combinations means first 4 0, then remaining 4 will be 1. Then 00 11 00 11, alternative 0 1 0 1 will write. Here, when all the inputs are 1, then only the output becomes 0. In other case, it is 1 here. This is regarding the NAND gate. Next one, NOR gate. The name itself suggesting NOR means it is a combination of OR gate as well as NOT gate. It means that the derived gate is derived from basic gates. In this, they collected OR as well as NOT are the few basic gates. Here it is used to construct. NOR gate has 2 or more input signals but only 1 output signal. NOR gate is a complement of OR gate. It is just reverse of OR gate. Whatever results we are getting in OR gate, just reverse of that. The output of NOR gate will be 1. Will be 1 when all the inputs are 0. When all the inputs are 0, then only the output become 1 here. See, this is a symbol for 2 variables. See, for example, x and y, or I can say a and b also I can take. Then output here, I am going to get x plus y. Once if it is negative, then f equals x plus y whole bar. If you want like the write like this way, otherwise consider x and y 2 variables. Same pattern, minimum itself 2 inputs will be required. Then reverse the C shape for OR operation. Then connect these two. At the end, you have to write one circle and then one line. Here x as well as y are the input. Here reverse C shape we have selected. That's why x plus y. Once here we are 0, then whole bar. If you want, you can write like this way or this way in the exam for NOR gate. It is a combination of OR gate as well as NOT gate. Here this is a truth table. In OR gate, NOR gate, 0 plus y, that is 0 plus 0 whole bar is 1 here. 0, 1, 0, 1, 0, 0, 1, 1, 0. Here when all the inputs are 1, 0. If all the inputs are 0, then only the output become 1. Otherwise, here it is 0. Now, is it clear? This is the symbol for 2 variable and this is the truth table for 2 variable in NOR gate. In the same way, in the exam, they are going to ask for 3 variable also. See, this is the symbol for 3 variables. Minimum 3 inputs, x, y, z. The output represents x plus y plus z whole bar. If you want, you can write like this way, or if you want, you can write like this way also. X, y, z. Here connect these two, and then here you can, whatever here we are going to get x plus y plus z. Once if you pass with NOT gate, then the result represent x plus y plus z whole bar. Like this way also you can write. If you want, you can write like this way or this way. Then both are correct. And this is a truth table for NOR gate. See, when all the inputs are 0, then only the output become 1. Otherwise, it is 0. See, 0, 0, 0, that's why output become 1. Whereas here, 1 time 1, that's why 0, 1 time 1, 0, 2 time 1, 0. All the inputs are 0, then only output become 1. In other cases, all the output becomes 0 here. Then here 3 variables means 2 to the power of 3. 8 combinations we get. 8 combination, first 4, 0 and the next 4 become 1. Next 2 times 0, 2 times 1. Alternative, then 0, 1, 0, 1, 0, 1. Alternative we have to write. Then output, when all the inputs are 0, then only the output become 1. In remaining all the cases, it is 0 only. This is regarding the NOR gate. Then you come to know NAND as well as NOR. The next one, exclusive OR gate. It is the next one, exclusive OR gate. In this exclusive OR gate also, you have 2 or more input signal and it produces only one output signal. 2 or more input signal and it produces only one output signal. Whereas here you have to count how many times the 1 is there. How many times 1 is there? Then if it is odd number of times, then only the output become 1. The main thing you have to count how many times 1 is there. If 1 is odd number of times, then the output become 1. Otherwise here it is 0. See, in exclusive OR gate, it produces output 1 for only those input combination that have odd number of ones. Otherwise here it is 0 here. And this is the operator we are using. In Boolean algebra, this is the operator we are using to represent exclusive OR gate. In the same way, for exclusive NOR gate also you have some operator, and or not. For everything you have separate operator, whereas this is the operator we are using to represent exclusive OR. See the symbol? This is the symbol to represent exclusive OR gate. First you have to write one reverse C and one more reverse C and then connect and then the final output. See, I will write it once again. Consider this is X and this is Y. 2 inputs, write down one reverse C shape. Then leave some space in between, one more reverse C shape and then connect this. Then output become X plus Y. For plus, you write one circle. This is the operator we are using to represent exclusive OR gate. See, here already I told you, we have to count how many times the 1 is there. Depending upon that, the output you are going to get. If it is odd number of times, then output become 1 here. Otherwise, here it is 0. See the first case. Consider 2 inputs, X and Y. The output become X plus Y. For plus, you write one circle. Then 2 variables means 4 combination. First 2 zeros and then 2 1. 0 1 0 1. In first case, we'll count how many times 1 is there? 0 times. That's why here 0. In second case, we will count how many times 1 is there? 1 time. That is odd number of times. Only 1 time we have 1. Then output become 1 here. In second case also, we have 1 as well as 0. You have to count how many times 1 is there. Only 1 time. That is odd. That's why the output become 1 here. See the second case, 1 how many times here we have? 2 times. 2 means it is even. If for even you have to write 0. For odd you have to write 1. Now is it clear? It means that you have to count how many times 1 is there. Then what do you mean by even numbers? For example, 2, 4, 6, 8 all are even numbers. 0, 1, 3, 5, 7 all are odd numbers. You have to count how many times 1 is there. If it is odd number of times, then we'll write 1. Otherwise, here we'll write 0. Whereas this is the symbol as well as truth table for 3 variables. See, minimum 2 inputs X, Y, Z. Then the output become X, Y, Z. For here, for plus, you write circle. That is the operator you are using. In the same way, for 3 variables, see X and then Y. Here 4 times 0, 4 times 1 will write. 2 times 0, 2 times 1, alternative will write. Then 0, 1, 0, 1 will write. See the output. In first case, how many times 1 is there? 0 times. 0 times means here it is even, then 0. In second case, 0, 1, we have 0, 0, 1. Here we'll count how many times 1 is there? Only 1 time. That is odd number. That's why output become 1 here. See the next case here. How many times 1 is we have? Only 1 time. Only 1 time is odd. Once again, the output become 1 here. See the next case. Here, how many times 1 we have? 2 times. 2 means it is even. That's why 0 here. Then here also 1 time. That's why odd 1. Here also 2 times 0. 2 times 0. 3 times. Then it is odd. That's why 1. Specifically in the exam, they will ask, write the symbol as well as truth table for 2 variable as well as 3 variable. The next one is X NOR gate. Exclusive NOR gate. It is a combination of X, NOR, OR gate. Then here in exclusive NOR gate, it is a complement of exclusive OR gate. In exclusive OR gate, we will count how many times 1 is there. If it is odd number of times, then we'll write 1. Whereas in exclusive NOR gate, we'll count in the same pattern 1 how many times here it is present. If it is even number of times, then we will write 1 here. See, exclusive NOR gate produces output 1 for only those input combinations that have even number of ones. Whereas in XOR, odd number of will count. Here, even number of ones will count. In Boolean expression, this is the operator we are using. That is, you have to write one dot. For the dot, you have to write circle. That's the operator represented for exclusive NOR gate. See the symbol here? This is a symbol for two variables. X and Y are two inputs. Exclusive NOR gate, because in exclusive OR gate, how we'll write? Two inputs X and Y. Here we'll connect. One more circle, reverse C, and then we'll connect. This is for exclusive OR gate. Whereas in exclusive NOR gate, here you have to write one circle and then one line. Exclusive OR gate. If you want, you can write like this way. Or X plus, here you can, if you want, you can write like this way. X plus, for plus you have to write one circle, then Y whole bar, like that also. If you want, you can write. Then when they come on truth table, first we will count how many times here we have 1, 0 times. 0 is nothing but here even 1. That's why 1 we have written. Here 1, how many times we have? Only 1 time. 1 is 0 here. Here also we have 1 time. That's why 0. When they come on here, 1 we have 2 times. If you have 2 times, then it is even. Then here 1 here. Andre exclusive OR gate alli nimge odd number of ones irbeku. Exclusive NOR gate alli even number of ones nimge irbeku. Then only the output become 1. Otherwise, here it is 0. Next, we will write the same pattern, symbol as well as truth table for 3 variable in exclusive NOR gate. It's also very important because specifically they will ask the symbols for 2 variables as well as for 3 variables. See, here we'll connect one circle here and then this is the output. Now, same pattern, here we have how many times we have? 0 times, that's why 1. Here, only 1 time, that's why 0. Here, 1 time, that is odd, 0. Here, 2 times, that's why 1. Here, 1 time, odd number, that's why 0. Here, 2 times, 1. 2 times, 1. 3 times, 0. Andre, exclusive NOR gate alli 1 na count ಮಾಡಬೇಕು. ಎಷ್ಟು ಸಾರಿ ಇದೆ ಅಂತ. If it is odd number of times, 0. If it is even number of times, 1. See here, how many times here we had 2 times, that's why 1. Here also 2 times 1. Here also 2 times 1. Here 0 times, that is even, that's why 1 here. Next, we'll explain how to write the circuit diagram for the given equation. Consider this is the equation we have. Because if you know how to write circuit diagram, then only you can write all the symbols and this can be predicted or it is used in Boolean algebra concept also. Consider we have an equation that is f of ABC equals AB plus AC bar plus B bar A bar C. Consider the equation that is AB plus AC bar plus B bar A bar C. Consider this is my equation. Now, how to write the circuit diagram? Totally, how many parts here we have? Totally 3 parts. One is AB, one more is AC bar, and one more is B bar, A bar, C. Whereas here, if you don't have any operator, then which operator you have to assume? Dot operator. Here also dot operator. Here also we have dot operator. Now, one by one we will write. First, I will take the first part, A and B. If you have dot operator, which is the symbol we are using? D shape. If you have plus operator, then that is OR operation, that is reverse C shape only you have to write. Now, first here I will take A and here I am going to take B. A and B. Here dot operator, that's why here I will write D shape. This is the first part output. Then I will take the second part, A dot C bar. I will take A as it is Next, one more I required C bar. That's why what I will do here, I will take C and then negate it. Then here, what is the output? C bar is the output. These two are connected once again. Dot operator. Dot operator means once again D shape. Next, we'll take the third part. B bar, A bar, C. First, I will take B. But I required B bar. Triangle here, at the end one circle and then one line. Then here, what is the output? Here the output is B bar. Then once again, I required A bar. Take A. And here it is A bar. Next, take down C. All the three are connected with the dot operator. That's why here I will write D shape. Okay. Now, all the three parts are connected by plus operator. Is it no? Plus means here reverse a C shape. Whatever results we have got, just select that and then write down here reverse a C shape. Then write down the output. See? Now, first output here, what is output? AB is the output here. Here, A, C bar is the output. Whereas here, B bar, A bar and then C is the output. These output are passed from this device, this circuit diagram. Then what is the output? One by one we will take the input, that is AB. Here, reverse C shape plus AC bar. Once again plus B bar, A bar and then C. This is the circuit diagram. Like this way, you have to write the circuit diagram. One more expression consider. X plus Y into X bar plus Z bar into YZ. See the equation. X plus Y, one part. X bar plus Z bar, one more part. And Y plus Z. Consider this is one more equation. Here three parts. X plus Y, X bar plus Z bar, Y plus Z. Consider three parts. One by one we will write the circuit diagram. First I will take X. Then Y. Here plus operator we have. That's why here reverse C shape, that is R symbol will write. This is the output here. Then second part will take X and X bar we need here. Then here one triangle, at the end one circle and then line. Then Z bar, Z is the input. Then here Z bar is the output. Plus operator, once again reverse C shape. Connect these two and then final output. The last part Y and one more is Z we required. In between once again plus operator, a reverse C shape we will write. Connect these two. But all the three parts are connected by dot operator. If you don't have any operator, it is assumed that it's a dot operator. Once again connect all the three with which shape? Dot operator. Dot operator means here D shape. See, what is the output here? X plus Y. Here X bar plus Z bar. Here Y plus Z. These are the output. When it is passed from this circuit, then what is the output here? X plus Y into X bar plus Z bar into Y plus Z. Okay, now is it clear? Then in the next class, you will come to know regarding NAND to NAND circuit diagram, NOR to NOR circuit diagram, how to write that as well as how to use that, how to write the circuit diagram by using NAND symbol only, how to write the circuit diagram by using NOR symbol only. That thing you will come to know in the next session. Thank you for all of you.